Thank you for inviting me to speak at this talk. I think it will give you some practice of listening to real English, because I actually come from England. Also, I think I was mainly invited because I'm going to make all the other speakers look young and slim. This talk has no formulas in it, I'm afraid, and is quite simple, I hope. I know it's really hopeful, but how many people do software testing in the room? Could you stick your hand up? Okay, 5. Right, so we've got about 200 people in the room, so the other 190 or so developers. Okay, maybe the rest came from the street. Okay, so I'm going to start with development, software development, and I'm going to start with software development because we have the most information as to how AI affects software developers and programmers. I'm then going to move on to software testing and how we can expect AI to affect software testing and how it will affect the entry-level jobs into the industry. I will also look at how we can make AI better when we're using it for software testing. And we have some standards, some international standards being built to actually support that. I'll also show you what standards are available if you're actually doing testing or if you're testing AI. So I assume we've got some people who sell tools in the room or outside maybe. And if you talk to people selling you test automation, they've been selling the tools for 40 odd years. And if their claims were correct, we'd all have no jobs, because if they were correct, 100% of testing would be automated. But in fact, it's way less than 50%. The AI tool vendors, so the people selling us tools to try and help us build systems, tell us that if you buy their tools, at a minimum, you'll get a 20% increase in productivity. If you're really lucky, you'll get 55% increase in productivity. If you're in charge of the financials for your organization and you see figures like this, then the first thing you're going to do is think, well, why am I using developers when I could be using these AI tools? Because whichever tools I buy, they're going to give me an increase in productivity. In which case, there is a really strong case, if you believe these figures, for actually buying AI tools to support development. So, what effect has this had? Well, throughout the talk, I'm going to be using this capability pyramid. And the capability pyramid, not to scale, the bottom part should be far larger. But at the bottom, we've got the junior developers, the people who are just coming out of university. Maybe after you've got 5 years experience, you move up, if you're good, to the middle layer. And then maybe after 10, 15 years, you become an architect or a principal engineer at the top. And again, you have to be very good to move up through this pyramid. So, let's look at some actual figures that are being reported at the moment. And I've picked figures not from Korea, because you all know what's happening in Korea. I've picked them from other parts of the world. So this is 2023 to 2025, and it's the United States. And what you can see here, just a minute. Yeah. This red bit here represents jobs lost out of the pyramid. So what you can see here is that 27.5% of programmers disappeared in that 2-year period. So the pyramid is now a slightly different shape because we've now lost those programmers. In that same period, if we look at the people at the top of the pyramid, they only fell by 0.3%. So the AI is taking the junior roles. And that's sensible because we don't expect it to be as clever or as experienced as the people towards the top of the pyramid. This is a global survey on entry-level hiring, and it says here, 2/3 of enterprises are reducing their entry-level hiring due to the availability of AI replacing the people. So as you can see, I've made the red part of the pyramid, which represents jobs lost, is slightly bigger. If we look at Europe, at the top there, you can see that in Germany, so where Claudia is from, who talked to us earlier, in 2025, the entry-level jobs was 40% below the 5-year average. So in 2025, it dropped by 40%. It's not just Germany, though. If we go to the UK tech companies cut their graduate roles from 2023 to 24 by 46%. That's nearly half. And a further 53% drop by this year. That's over half. I don't know firsthand what it's like in Korea, but I can tell you in the UK, if you've recently come out of university and you're expecting to be a developer, a programmer, it is extremely difficult to get a job. You have to send literally hundreds of applications, most of which won't even be responded to. So you have to be lucky to get a job. Going back to the United States, so this is the impact of generative AI on early career professionals. And again, you can see here, we've got a 2/3 drop in people advertising jobs for the entry level between 23 and 24. The red bit is getting bigger. These are US unemployment figures, so these aren't people's guesses. These are actually the people who can't get jobs. And what you can see is that if you're a new graduate in the United States, the unemployment rate was nearly 10%. So 1 in 10 of all new graduates in the United States couldn't get a job in 2025. That's double the rate of the whole of the United States. So new graduates, you're twice as worse off as the average of everyone. And it's 4 times as bad for all graduates. So the people who are older, the people who got into work earlier, 10 years, 20 years ago, basically they're all right. Their unemployment rate is about 2.4, 2.5%. But if you're a new graduate, it's 4 times as bad. So for some reason, it's a bad time to be employed if you're a new graduate. So what we can see is that there's an ongoing trend. And I'm interpreting across to 2030, it's going to get worse. It's going to get worse because more people are going to be buying AI and more people are going to be expecting the AI to be able to do their jobs. So there's something called the AI productivity paradox. I showed you similar figures or a similar slide at the beginning. It was from the vendors. And the vendors said you would get increases. The minimum increase in productivity by using AI tools would be 20%. But it could go up to 60%. So they did an experiment with tens of thousands of developers. And what they did was they asked them, they gave them AI tools, and they asked them how much that had increased their productivity. And the average was 20%. So it appears that they were quite conservative in guessing how much the tools had helped them. They then actually measured how more productive they were. The people using the AI tools were actually 19% less productive. So even though they thought they were more productive, and they thought they were more productive because the tools help you generate loads more code. The trouble is, when they generate loads more code, they generate loads more bugs. And then someone has to fix them. So in fact, using the tools is actually making people less productive. However, that won't stop the people in charge of organizations thinking the next tool will be better and it will save me money. So they're going to carry on making purchases of these AI tools and reducing the number of jobs that are available. Have I cheered anyone up yet? So what we're seeing is that at the bottom of this pyramid, the jobs are disappearing. And as with all pyramids, if you take away the stuff at the bottom, it makes the whole pyramid unstable. Because if you take away the jobs at the bottom, then after a little while, there's no one to go up. Because the way these pyramids work is that you start as a junior developer, and then after a few years, you move up if you work hard enough, if you're clever enough, and then after a few years, you move up again. But if we take out lots of the people at the bottom, then in 10 years' time, we won't have anyone to move up this pyramid. And the people at the top of the pyramid are the people that we really need to make sure that the AI we buy is actually doing the right thing. Because I'll show you in a few slides' time that actually using Gen AI is not the solution to everything. So if we take out that big red chunk, our pyramid looks like this. Now, this is my guesswork from those figures, but you can see here, here's another figure. 71% of businesses reported increasing difficulty recruiting future leaders due to the loss of entry-level learning pathways. If we cut off down here, there's fewer people to go up there. And the industry can't cope with this forever. We could just hope that AI will get better and better. And AI, of course, will get better and better, but will it get good enough? Well, for programming, my guess is, yeah, it probably will. Programming is really simple. Sorry for the developers in the room. But Programming, you get a nice spec, you translate it into code. You can also get immediate feedback on whether it compiles. So if it doesn't compile and you're the AI, you go back and say, okay, something went wrong, I'll fix it. Also, if you run a few tests, you get immediate feedback. So if it compiles, then you execute it against some tests. If the tests fail, again, you get immediate feedback. So from a developer's perspective, building AI tools is relatively simple. And the other reason it's relatively simple is that the people building them are developers. So they don't have to go away and talk to some third-party expert to say, what should it be doing in this situation? They actually know themselves what it should be doing. So it's quick, easy. So from a developer's point of view, I definitely wouldn't be aiming to get a programming job in 5 years' time, because there'll be very few jobs. But we're at a conference on testing, so sorry about all that stuff on development, but hopefully you'll see that it's relevant. So we can build the same pyramid for testing. At the bottom, we've got people called testers, test analysts. As we move up, we've got test leads and the managers. And at the top, we've got the consultants or test architects. In effect, it's a very similar structure. And we've got loads more people at the bottom, and it gradually goes up. So on the left there, it says developers cost more than testers. So the people in the room who admitted to be developers, the chances are you're getting paid more than the testers. And the testers in the room are probably quite envious of the developers who get paid more. I actually went and did consultancy in one organization, actually in Texas, and they actually put all the testers in a separate building to the developers because they didn't want the testers to find out how much they paid the developers. The difference was so large. I think it applies globally. So from a productivity view, replacing developers saves you more money than replacing testers. In which case, from a tester's point of view, it'll be a bit longer before we lose our jobs. Testing, though, costs more than development. Even if we have bad developers, the developers only take up about, on average, 30% of our project budget. When we actually add up all the testing that has to happen, and if we include the testing of fixes when they put bugs in, and we include the testing for regression, then the testing costs a lot more than the development. So on the left there, that's not going to make people want to put AI into testing, or not as quickly. But on the other hand, if they work this one out, then they'll be thinking, oh, actually, we spend more money on testing overall. So let's get some AI to do the testing. The good thing is that most of these people high up in the organization have no idea that the testing costs so much. So we could just keep it secret from them for maybe another 5 years. Now, I explained why programmers or AI assistants for programmers are actually quite easy to build. For testing, it isn't so simple, because when we're testing, especially at the system level, we need to know about the application domain. because we need to decide after a test runs, is that a pass? Is it a fail? Is it nearly a pass or nearly a fail? We also need to use risk-based testing, which means we need to understand the impact, if it does fail, on the business. And a lot of AI don't have this information about the current projects because they were trained a year ago. So they don't have this up-to-date information. Testing also requires us to understand what the system is supposed to do, even when it's not written in the specification. Because a lot of the time, the specifications are awful. Well, in fact, most of the time. And they're incomplete. And because they're incomplete, when we run a test, the tester can't just look at the specification and say, oh, well, the specification says that, therefore it passes or fails. Instead, they have to use their common sense. They have to use their experience. AI doesn't have common sense, and AI doesn't have that experience. Also, testing's feedback loops are looser and more contextual. So the feedback loop depends on the application domain. It depends on what the customer's asked for. And the feedback loops are longer because a lot of the time we have to have the expertise to actually know, did that test pass or did it fail? And as you saw from the previous talk, if we're testing complex AI systems, we can't immediately see whether something passes or fails. Testing also requires creative thinking, and it requires thinking along the lines of, how do I break this? These are things that AI isn't especially good at yet. So because testing is not as simple as programming, we haven't had so many of our jobs taken away yet. But that doesn't actually mean that that won't happen. So if it requires all this judgment and human alignment, can AI actually do testing? No, it can't do the whole job. So that's good news for the testers in the room anyway. But it can do the simpler tasks, which is bad news for the testers in the room if all you do is simple tasks. So you need to think about it. Oh, I spend all day executing tests. Well, if that's all you do, the AI can take your job really quickly. You need to be moving up the pyramid and doing more complex stuff. And the AI will get better. We've got all these new technologies coming along. We've got people working in universities to make it better. So it's only a matter of time before it will be able to do quite a lot of the tasks that testers do today. So with AI, we have a 90% problem. And I'm using 90% just as an example figure. It's my experience, but what I can safely say, if you wanted to argue, it's not 100% right. It's always a bit wrong. So for 90% of the time, AI will generate nice, structured, well-defined tests. It will generate documented requirements. It can nearly always do regression coverage, and it's good if it knows what the failure modes are. And it'll get that right 90% of the time. However, there's about a 10% when it doesn't get it right. On the edge cases, on emergent behaviours that we hadn't predicted the system would have. Implicit requirements where the requirements weren't written down. But the people who were testing it had worked in the organisation for the last 10 years and knew what the system was supposed to do. The AI hasn't worked there for 10 years, and therefore the AI doesn't know what it's supposed to do. And there are domain-specific constraints which the AI doesn't know as well. So 10% of the time it gets it wrong. Now, if you're just trying to save money, you can look at this and say, well, I'll get rid of most of the testers because it's right 90% of the time. On the other hand, not many customers are going to want only 90% of the functionality to work, or 1 in 10 words coming up completely wrong on the translation. And the 10% isn't random, it clusters, which means bits of the system will really fail. Other parts of the system will appear to work fine and will work fine. But the bits where the bugs are could be the important parts. So if we follow the same as we looked at for development, but apply it to testing, you can see, my guess is, we're 2, 3, maybe 4 years behind. But AI is getting better all the time, and that red bit is going to disappear unless we do something about it. Which isn't good if we plan to be working as testers in 2032, unless we've managed to get to the top of this pyramid, in which case you can just look down and laugh at them. So you don't learn as a tester about being a good tester, recognizing failure just by reading about it, or just by going on an AsiaSTA QB course. Traditionally, junior testers run real tests on real systems. They see things going wrong that they weren't expecting. Senior testers come along and make some decisions. That doesn't matter because the impact is 0. That doesn't matter because the probability of that happening in the real world is 0. And they learn. So they get some pattern recognition built up over time. And then after 5 years, they move up the pyramid and start advising other people. If we use AI to execute our tests, it runs the test. So the testers, the people at the bottom of the pyramid, a lot of those people doing test execution, that job has just disappeared straight away because test execution is really easy to automate with AI. The AI produces outputs. Now, all of you that have actually used Gen AI will know that Gen AI is really confident. When it gives you answers, it will give you nice, plausible answers, and it will be very sure that those answers are correct. But it's not all the time. But if it's plausible looking and you're rushing, the junior testers don't have the patterns, if they're just working with AI, to know when the AI gets it wrong. Those are the people higher up the pyramid. The junior testers can't see what was missed, what tests weren't run. So that pattern recognition about where systems go wrong, where to generate the next test, is never built up. And that means if we move straight to using AI to take away as many of the tasks as possible, then our junior testers are never going to get enough experience to move up that pyramid. And in fact, there won't be many of them because the AI is actually going to do quite a lot of their jobs. So Gen AI is really useful. This picture, 2 prompts with ChatGPT, really impressive. I should say 2 prompts generated by Claude put into ChatGPT. I didn't make up the prompts myself because that's too complicated, especially when I've got Claude to do it as well. But what you can see is we're going to have people coming out of school, coming out of university, And if we take away all those junior roles, there's nothing for them to do, which is why on the developer side, there are so many people finding it difficult to get jobs. This is going to happen to testing as well. We're just 3-4 years behind. We have to do something about it now. Or we could just wait, but that's not very responsible, and it will probably cause a disaster. We've got to have some way to get across this gap. So, how do we actually fill the gap? Well, we could have paid apprenticeships. Now, we have paid apprenticeships in many countries where people are put in 18 years old, get paid, learn how to be a tester. But we need them to be in there longer if we're going to teach them all the skills they need so they can cross that gap to get to the middle of the pyramid. And the trouble is, extended paid apprenticeships cost businesses a lot of money. So they're not going to be very keen on actually going for that one, which is why I've got a question mark there. We could have closer university-industry partnerships. Well, we've been asking for that for 40 years. I worked in university for 18 years. Really difficult to actually get anyone in industry to give us real stuff to play with. For the last 18 years, I've been out of university and in industry. Now it's really difficult for me to get anyone in university to take me seriously because they're all academics and I'm just a practitioner. So getting that to work is really tricky. Another question mark. The 4 that we actually want, I think, at the bottom of the slide. We want competency frameworks based on practice rather than knowledge. So we want ISTQB certification schemes that aren't just remember this, aren't just understand this, they're hands-on, practical, and teach people real skills that we need in the era of AI-assisted testing. Now, so I think testing has got to change. It can't just do what it was doing before with AI because we'll lose all the jobs. So, what do we do with the junior testers? Well, the bottom 3 bullet points here show what I think we could possibly do. The specification is the new testing ground, so we get testers to review specifications, every specification, because we've got specifications going into the AI based on development, and we've got specifications going into the AI for the testing. We want AI testing tools that don't just do the testing job, but teach the people who are using them. And we need process improvement because the AI, as we know, isn't perfect. Therefore, we need to make it better. And the best people to make it better are these junior testers. So, looking at the first one. Before AI designs, because it will design and execute the tests, the junior tester reviews the specification. So the tester challenges whether or not it does what it's supposed to do. Does the specification say what wants to happen in the real world? They should be able to recognize the unwritten parts of the specification which are just assumed everyone knows about, but of course the AI won't know about. And if AI writes the specifications, what we want them to do is say, okay, that looks really nice, but actually it looks nice, it reads really well, it's plausible, but it's wrong. So we have to give testers the skills to actually identify these, because basically AI can't do that. And if we can make those specifications that go into AI development and AI test tools better, then our productivity doesn't go down, our productivity goes up. The second point. So the first point is get the junior testers to do something before we even execute any tests, before we even design any tests. The second point is that when they're actually using the AI testing tool, we want the tool to help them learn what it's doing. The professor was saying we want explainability in our tools. We want the tool to be more than just explaining what it's doing. We want it to actually actively engage with the user. So actually challenge the junior tester to say, which option do you want? I'm giving you 3 options here. Which is the best option, do you think? And if they choose the wrong one, it comes back, hopefully, and questions that. So we have to build into the AI not something that is just very polite and just does whatever you ask it to do, but something that actually challenges and therefore teaches you at the same time. And of course, if we are building this into an AI tool, the AI tool can adapt to every single tester. Some testers are cleverer than others. Some testers have more experience than others. What we want is a tool that doesn't just give the same feedback to everyone. We want a tool that says, okay, this one's Fred. Well, I know Fred is not very good in this area, but Fred's quite good in this area. So that when I give them feedback, I'll try and hit that area where they're not very good, to try and teach them. We have adaptive learning systems with AI already in many other areas. All we need to do is move the technology into testing. And that gives us a dual optimization goal. So the tools should want the actual testing to go better, but we also want to optimize on the testers as well, so the tools actually improve the testers at the same time. And the third one, and I should say I'm using Sunny version 9 here instead of version 11 because this is an old version. So we get a test specification. We feed it to our AI testing tool. It gives us a tested system. System crashes or fails. We get reports back that something's gone wrong. There's a defect in production. So what do we actually want to happen? Well, we want our AI testing tool to get better. How do we make AI testing tools better, or any AI better? We retrain them. Yeah? If we know it goes wrong, we give it more data or better data and retrain it. In which case, we get our junior testers to do a defect analysis on what went wrong, and then they identify the new testing knowledge that the AI tool needs to have. So they're building up an improved database or knowledge base for the tools. The retraining occurs, and we get an improved testing tool. Yeah, I'm going to ignore that, thanks. Sorry, I was just ignoring the timing. We need the tools to get better. We expect the tools to get better. But if we build it like this, our junior testers get better as well. So even though we've taken away lots of the tasks they do, we can actually improve their skills. Okay. So, what do we need to do? We need to be proactive. Don't wait 3-4 years and just see what happens. We can see what's happened to developers already. There's no point waiting. If we wait, it will just be a bigger disaster than if we do something now. So for organisations, we need to protect the junior roles. There have to be junior roles because otherwise we can't get people moving up the pyramid. And I've just explained where we can use the junior testers for pre-testing to make sure the specifications are good, and for the process improvement to make sure that our AI testing tools get better over time. For the profession as a whole, we improve the certification. These new skills we build into certification schemes. So whereas before we had theoretical knowledge-based schemes, now we actually build some practical hands-on schemes that are aimed specifically in these areas. And for the tool vendors, we want them to design testing tools that don't just do the testing, but also develop the testers. Okay, so that was the first point. So, if we're building AI testing tools, is the testing knowledge available to us? Some. If we've got a tester using Gen AI, they generate a basic prompt, it goes into the LLM, comes back, and we get a basic response. Yeah, we've all done this. We all do this many, many times a day. I did last month, I asked latest version of Gemini, provide an example of a defect. And this is what it came back with. Now, for those of you who've done ISTQB and remember as well, which are two completely different things, this is wrong. So, that was my first prompt. That's what it came back with. And then I said, well, just a minute, isn't the example provided of a failure? Because it wasn't a defect. Gemini, very polite. You have a sharp eye. Good. I've only been doing this 40 years. You're absolutely right. Here's a corrected example. And it gives me another example. And then I look at that and I think, but isn't that a mistake or an error? That isn't actually a failure. Or, sorry, a defect. You're on a roll, and you're exactly right again. Great. Okay. I know ISTQB in a lot of depth, so it's easy for me to see these mistakes by the LLM. But I would guess that 90% of people would just not notice that there was that there was something going wrong there. Because the large language models we've got at the moment are only 90% correct. It's nearly right, but it's not quite right. And if we need it to be perfectly right, maybe we're building a safety-related system, then using these tools as they are now is just not good enough. And why do we get this situation? Well, when we build an LLM, we generate loads and loads of data to throw at it. The trouble is, when we get this data, we're getting it from blogs, white papers, whatever, stuff off the internet from 20 years ago, and there's loads of stuff on the internet from 20 years ago, which is wrong. And the trouble is, someone wrote a website, put some wrong stuff on it. It was nearly right, but it was wrong. And then somebody else copied it, because IP doesn't mean much 20 years ago on the internet, and probably not so much now either. And so we ended up with various websites, all with the wrong information. But that's the information that we use to train the LLMs. Well, I say we use to train the LLMs. Actually, the LLMs train themselves because it's self-supervised learning, but we give them the data. And if we give them bad data, they're going to end up giving us bad results. So how do we get around this? Well, the way to get around it is using something called RAG, which is retrieval and augmentation. So what we can do is we can provide correct information to the LLM, specifically on testing, if we're doing a testing task. And the way we do this is by giving it access to a testing ontology. The testing ontology is all the information we have about testing, all the concepts, their relationships, their definitions. Now, clearly, if we're going to do this, the ontology has to be correct. And so what we're doing is actually, we've started an ISO project to actually build a testing ontology based on the information that's in ISO, in ISTQB, and anywhere else we can find it. So the ontology has two basic parts. It has UML class diagrams, and those are human-friendly. In as much as if I show you a UML class diagram, you'll have a fairly good idea of what it's telling you. And from those, we can generate our two descriptions. So this is web ontology language. So this is a formal language. You don't want to read this. It doesn't mean anything, but it's machine-friendly. So far, we've got 510 classes. So 510 different concepts from software testing, which is larger than any other testing ontology that's been built so far. But we can feed the OWL2 descriptions into the large language models, and they can understand them, which means they won't come back with silly answers that are not quite correct. The other things we can do is actually check using tools. So this is the smallest class diagram, and it covers the part, well, the question that I asked Gemini a bit earlier. So this is what the class diagrams look like. And the OWL descriptions look like this, but there's a big gap there because it goes on for pages and pages. So our testing ontology is largely based on the ISO standards. The ISO standards since 2007 have been the ones in the dark blue at the top there, the ISO 29119 series. We've got reviews, we've got incident management, and down here we've got a new set of standards on testing AI. And these are all the areas that are currently covered by the ontology. So I was asked to cover standards. So the Working Group 26, which I run, has produced or is producing these standards. I recommend them, obviously. And these standards, as you can see here, the testing ontology is currently being drafted. And I'm also the co-convener of the AI testing ones. So it's a joint group between software engineering and AI. And we have these standards. And as you can see, we've even published some of these. And in fact, the one at the top there is actually freely available. You don't even have to pay for it. The ontology, my guess is ISO will try and sell it to you, but the actual ontology itself that feeds in to the LLMs will be provided free on a website. So anyone building a tool will be able to take that and actually use that ontology to help build their AI-based tool. So at the moment, we're getting basic AI testing tools. AI is advancing. If we build those advances on this foundation of this testing ontology, hopefully the tools up here will be far better and not just 90% right. So, conclusions. The AI tools will take entry-level jobs. We've seen it in development. It will happen in testing. If you're a junior tester, look at moving up the pyramid. Look at expanding your skills. The AI tools already do the simple testing tasks, but they're not as capable as many people would like them to be. We've got to create a new role for junior testers so we don't lose everyone. Otherwise, the pyramid collapses. So we've got to create these new roles, checking specifications, improving the AI, and using tools that teach you to make sure our junior testers actually still come into the industry and are available to move up the ladder. But we'll need less, I'm afraid. So there'll be fewer testers, hopefully, well, not hopefully, they will need to be higher capability, but they will also be better paid. We need an agreed testing ontology, otherwise future testing tools are only going to be 90% right. There's a number of standards, of which the 42119 series are the ones that are specific to AI testing. AI is going to get better and better, and we've got to make sure that our testing keeps up with it. Okay, I assume I don't have time for questions.